Hi students, today in this video I am going to cover a very important and interesting topic from 2D kinematics, which is the projectile motion. So we are going to analyze the motion of the projectile in the xy plane. So before we start, let's try to find out what is a projectile. It is actually an object thrown into space such that it moves under the force of the gravity alone. Here we assume that it is not acted upon by any other force like air resistance or buoyant force. Okay, so here it has actually the motion of the projectile is the resultant of two independent simultaneous motion, one along the x direction, another along the y direction. Okay, in the x direction the body is moving with constant velocity. That is, if we assume that the body is projected with initial velocity u, then we, making an angle theta with the ground, we resolve this u velocity into two components, one along the x direction, which is ux, another along the y direction, which is uy. So uy will be u sin theta and ux will be u cos theta. Now this u cos theta remains unchanged along the x direction till the landing position. Why? Because along the x direction the body, that is the projectile, will not be acted upon by any force, whereas when the projectile is rising gradually and after attaining the maximum height, it is descending downwards to the landing point. All along this path, it is acted upon by the force of gravity at all points. At all points, it is acted upon by the force of gravity. Since a force acts on the body at every position, its velocity will not remain constant. So it will keep varying. Okay, so the acceleration will be uniform acceleration, which is the acceleration due to gravity, but the velocity will not be uniform along y direction. Okay, so let us analyze the motion parameters along x direction and y direction. First of all, its position at the initial time t equals to 0. It has started, say let's take the initial position to be the origin, so x equals to 0 and y equals to 0. Initial velocity along x direction will be the component of u along x direction, which is u cos theta, and the initial velocity along y direction will be the y component of u, which is u sin theta. Along the x direction, ax will be 0, no acceleration. Along y direction, ay will be minus g. Why minus g? Because acceleration due to gravity is directed downwards along the negative y direction. That is why the minus sign. Okay, so we can write this. Next, after time interval t, let's find out the position of the projectile. Now its position will be given by two coordinates, one along x axis, suppose it is here after the time it got projected. So in a time t it reached to this point. So its coordinates will be given by x comma y. X is this one and y is this one. X is this and y is this. So let's try to find out its position after time t. X will be ux multiplied the time. We substitute ux with u cos theta multiplied time, and y coordinate will be obtained by using the second equation of motion. In place of uy we write u sin theta, in place of ay minus g, and that gives the y's value, that is the y coordinate of the position of the projectile after time t. Now coming to the velocity part, along x direction the velocity at any place along the x-axis will be same as the initial velocity, which is u cos theta. Along the y direction, what will be the velocity? It is given by the first equation of motion, uy plus ay into t. In ay's place we write minus g, in uy's place we write u sin theta, and that's how we get vy equals to u sin theta minus gt. Now notice one thing, when the projectile is rising up to the maximum height, the direction of the force and the direction of motion are oppositely directed, and so the velocity will during ascent vy will decrease. At max height, at maximum height, what happens? Vy will be 0. The body will have only velocity along x direction. So here only v equals to vx, no vy. Now when the body starts falling, again it will have, suppose at this point its velocity is v. So v can be again resolved into two components, one along the horizontal and the other along the negative y direction. Now at this point, or say any other point when it is falling, the direction of gravity and the body's velocity, that is body's motion, are in the same direction, that is vertically downwards. So here the velocity will keep on increasing. Now when it lands, the vx is same as ux and vy will be negative of uy. Here uy remains the same, that is their magnitude, here also uy, here also uy, but here it is positive uy and here it is negative uy. So naturally when we find the magnitude of this velocity v, it will be the v will be given by root over of v is equal to root over of ux square plus vy square, and that will remain the same as u. Hope it is clear to you. So you have to remember that at max height the body has only x component of velocity, no y component of velocity, and during the ascent part its velocity keeps on decreasing up to the maximum height, and then when it descends its velocity increases. The direction of the velocity of the projectile with the horizontal, that is if we want to find theta, we have to take tan theta equals to vy by vx at any instant, say at this instant here. It will be given, this is vy and this is vx. So tan theta will be, if this is theta, then tan theta will be given by vy by vx, that is perpendicular by base. Now let us try to find the equation of the trajectory, that is the path of the projectile. So for this we are taking the second equation of motion, and first of all we substitute uy with u sin theta, and in place of ay we write minus g. Next our task is to eliminate this time. So time is along the x direction, see we find the x coordinate of position by multiplying ux with t, and in ux's place u cos theta, so t will be equal to x by u cos theta. So t is given by x by u cos theta, that we substitute in place of t. And doing that, we get this equation, which is y equals to tan theta into x minus g upon 2 u square cos square theta into x square. Now this takes the form of this equation, y equals to ax plus bx square, where a and b are constants, and this is the equation of a parabola. Here also we find that this equation resembles this equation of parabola. So we can say that the trajectory of the projectile is a parabola. Now let us find out the time of flight, that is the total time of flight. That is, when the body was projected, it attained the maximum height, and then from the maximum height it landed to the ground. This whole time is the total time of flight, which is denoted by t. For this we are using the first equation. In uy's place and ay's place we wrote all the values, and that gave us the expression for vy. Now at max height, already discussed, vy equals to 0, so put here 0. This is becoming 0. So if this becomes 0, then u sin theta equals to gt. From here t equals to u sin theta by g. Now this time is the time taken by the projectile to reach from its starting point, that is the projection point, to maximum height. Now the same time will be needed by the projectile to land from the max height to the landing point. So the total time of flight will be capital T equals to 2 times of the small t. That is, from here to here time taken is t, and from here to here again the time taken is t. So t is equals to t plus t, that is 2t. Okay. So we got the total time of flight, which is 2 u sin theta by g. Next is the maximum height attained by the projectile after it was projected. So for that we are using the third equation of motion. Here we are again writing vy equals to 0 at max height. Substituting all the other values, we get h equals to u square sin square theta by 2g, where h is the max height. Next is the horizontal range r. It is the distance along the x direction of motion, that is along x-axis, between point of projection and the point of landing of the projectile. That is horizontal distance traversed during total time of flight, capital T. So to find distance, we multiply speed into time. Speed is ux and total time is the total time of flight. We substitute the values of t and ux to get u square 2 sin theta cos theta by g. Now 2 sin theta cos theta is sin 2 theta. So we write this u square sin 2 theta by g. This is the expression for r. Now if you are asked to find the maximum horizontal distance covered by the projectile, for that we have to get this value sin 2 theta to be maximum. For that we need 2 theta should be equal to 90 degree, hence theta will be 45 degree. So for if the projectile is projected making an angle 45 degree with the horizontal, if it is projected making an angle 45 degree with the, if theta is 45 degree with the horizontal direction, then we know that the range will be maximum and its value is given by u square by g. Hope the basic concepts of projectile motion is clear to you. If you like it, do hit the like button, and if you have any suggestions or queries, you can put it up in the comment box. Hope to meet you soon with another interesting video. That's all for today. Thank you.